Good morning, everyone. Good morning.
Good morning, ma'am.
Yes. So,
Good
sir
morning,
has,
ma'am.
good morning, ma'am. Sir has said a wonderful point. It's a valid point. See, the main thing we have to do is you have to talk to your seniors. So, talk to your seniors and get maximum points. Definitely, they have a much experience. Though they'll say that what mistake they did. So, it will be in very useful to you. So, you will not do that mistake, right? So, experience is always a better thing. So, ask your experienced teachers or the students like your seniors. They'll say many points that will be useful for us. So that is what sir did now. Yeah, so we will continue the structure of atom lesson. So what we discussed in the last class, any one of you? Yes.
Madam, that
We
off bar
discussed
principle is there, na? That off bar
Yes,
principle.
sir.
That one question I gave,
Okay, sir.
and I think they were able to answer. That's a
Okay, sir.
tough question. I
Oh,
gave off bar
okay, sir.
principle on the moon irukilya. The
Yes, sir.
three, that is, what is that, expected configuration and actual configuration
Yes,
is
sir.
different.
Yes, sir.
நான் என்ன கொடுத்தேன்னா ஆல்வேஸ் டிஃப்ரெண்ட்னு கொடுத்துருந்தேன்.
Oh,
ஸோ இட் இஸ்
okay,
நாட்
sir.
கரெக்ட். இட் இஸ் டிஃப்ரெண்ட் ஒன்லி ஃபார் சம் எலிமெண்ட்ஸ். am I correct, madam?
Yeah, sir. Yes,
அதே
sir.
மாதிரி இட் இஸ் சிமிலர், ஆல்வேஸ் சிமிலர்னு கொடுத்துருந்தது. அண்ட் தேவர் ஏபிள் டு ஃபைண்ட் அவுட் தட்.
Oh, that's
ஸோ
good,
அது
sir.
வந்து எனக்கு ரொம்ப ஹாப்பி. பிகாஸ் ஐ சாட் ஆன் யுவர் கிளாஸ். அந்த மெமரி
Okay,
வச்சு அப்படி கொடுத்துட்டேன்.
okay, sir.
ஒன்லி திங் இஸ் ஆடட் தட் வேர்ட் ஆல்வேஸ்.
Yes, sir.
ஓகே, ரைட், தேங்க்யூ.
Yes, ma. Who is ready? What we discussed in the last class? Yeah, any one of
ma'am,
you?
we discussed isotome. No, ma'am. Isotopes, isotones, and alpha principles, isobars.
Super, very good. Isotope. So the structure is about the lesson is about the structure of atom. And what is the atom structure? What is the structure of atom?
Spherical, ma'am.
Very good. It is spherical shape. Yes. And what are the subatomic particles? Subatomic particles are?
Yes, PDF.
That is subshell. I'm asking subatomic particles. Others also can answer.
Is it proton, neutron, electron?
Yes, sir.
Ah.
It's proton, electron, and neutron. These are all the subatomic particles we learned. And then what is the charges of the subatomic particle? Where these particles are located in the atom. Then what is nucleons? What is nucleus? Everything we learned. And then how to write the electronic configuration, about the isotope, and then isobar. Very good, super. So the next one is, next we are going to, in this class, we are going to learn discovery of electron. Okay, it's kind of a history based, like who found this and then how found this. So who found the electrons, then what is an experiment he did. So that is what we are going to discuss in today's class. So mostly from this area you have very less questions. So mostly it's a theory. Like from the Bohr's model, we have Bohr model and then line spectra. From that area, we can expect maximum question. Anyway, this is in your NCRT book, so that we will see how the electron was found. Ready, everyone?
Yes, ma'am. Yes, ma'am.
Okay. Okay, very good. Okay. So, about discovery of electron. Any idea about who discovered the electron? Who discovered the electron? No. J.J. Thomson. J.J. Thomson only discovered the electron. Based on what experiment? It is an cathode ray experiment. So what is it called as? Cathode ray experiment. So for this experiment, he took a glass tube like this. Okay, this is a glass tube and he is fitted with the one negatively placed electrode and then the other side is positively placed electrode. So what is the name of the negative electrode? What is the name of the negative electrode called as? Yes.
Cathode.
Yes, it is a cathode, right? This electrode is actually a cathode and then this is your anode. So the cathode is connected to the negative terminal of the battery, and then the anode is connected to the positive terminal. Because of this reason, these electrodes have negatively charged particle. As the negative part of the battery is connected to the electrode, this becomes negative, and this the other one become a positive. So this is connected to the vacuum pump. Okay, what is a vacuum pump? What is the use of vacuum pump? Yeah, students, what is the use of vacuum pump?
Hitting the air inside it.
Very good. We can control the pressure and we can take the air molecules from the glass tubes. So this will control the pressure. So this is our vacuum pump, which will control the pressure inside it. And this experiment was happening with a very, very low pressure. So to control the pressure, we are using it. So the experiment is taken place at low pressure, and then we are supplying an electricity, right, which is extremely of higher voltage. So this is what he did. Okay, the high voltage he took. Okay, then he is passing the hydrogen gas inside the glass tube. Now what is happening means some of the rays are coming from the cathode, but this is an invisible ray. We can't see these rays. Some of the invisible rays are coming from the cathode. So how he proved it? See, I think most of you know of basic points. In case if you know means tell me, so that we can discuss properly, right? So how they are finding? This is an invisible ray. Then how he found the rays are coming from the cathode? Why it is not from the anode? Any idea, students? The rays are coming from the cathode. How he is proving means he has some coated zinc sulfide on the side of the anode. Okay, this is a coated zinc sulfide. He has coated some zinc sulfide on the anode side. So near to the anode side. What is a zinc sulfide? Zinc sulfide is a phosphorescent material. Phosphorescent material means something which falls on the zinc sulfide means it will start to glow. So the rays are coming from the where? The rays are coming from the cathode. Once it touches the zinc sulfide, it will start to glow like this. It will give you a spotlight. So from that we can understood the rays are coming from the cathode. Okay, it's a kind of history and experimental oriented. It's a bit difficult to follow up. So try to be in the line. Okay, so the cathode. So from the cathode the rays are coming, and it is an invisible rays. So how he said the rays are coming from the cathode is, so he coated zinc sulfide on the side of anode. So the rays are falls from the cathode and it touches the zinc sulfide. So it starts to glow. So that's the reason he found that some rays are coming from the cathode. Are you people clear? Is there any doubt in this point? Clear, everyone? What is a zinc
Yes,
sulfide?
ma'am.
What is a zinc sulfide? What is the purpose of zinc sulfide here? It is a phosphorescent material. When any material strikes on the zinc sulfide screen, it will start to glow. Okay, the rays are invisible and it touches the zinc sulfide, so it starts to glow. So he proved that the rays are coming from the cathode. Next, what he is doing is he is placing a small fan kind of a object in front of the cathode rays. So the cathode rays is coming and it touching this object. So what will happen? Whether it will start to rotate or not. Here we have placed some fan. So the rays are coming. Whether the rays will rotate the paddle or it is and rotate the fan. Yes, students. Yes or no?
Yes, ma'am.
Yes. It means that the rays are actually an particle. Okay, the ray has some mass. So because of some masses only, the fan starts to rotate. Okay, the ray has some masses and it is a particle. This is a next conclusion. So it is a particle. This is the next point. So he proved that it is some invisible rays coming from the cathode and it falls into the zinc sulfide. It starts to glow. And the next point, whether this particle whether this invisible rays has some masses or not. How
Ma'am,
we
what will
prove
be
it?
the weight of the fan, ma'am?
Sorry?
Ma'am, what will be the weight of the fan, ma'am?
It is very, very light. See, imagine the electrons are very light particles, right? This fan is very, very, very light. So that only because imagine the wind is very, very light. Whether the windmill starts to rotate, no?
No, ma'am.
Yes or no?
Yes, ma'am.
So the wind is very, very light. The wind is very low speed. So the windmill will not start to rotate because whenever you have a very much high speed of wind, then only the windmill starts to rotate. So the invisible particles means having a very, very light weight. That's the reason it is invisible because we cannot see a microparticles. So the invisible rays has very light mass. So he did a fan having a very, very light weight. Clear, ma?
Yes, ma'am. Ma'am, I have a doubt, ma'am.
Yeah, yes.
Ma'am, you said no, ma'am. If cathode rays, the rays are coming from cathode, then it starts to glow, ma'am. Like
Yes.
ma'am, suppose if the rays are coming from anode, what will be the effect at cathode side, ma'am?
So we can place the same zinc sulfide on the side of a cathode so that we can get the anode, we can see the anode rays.
Yes, ma'am.
That is what actually the next experiment we will see one by one.
Okay.
Yeah. So I think clear, right? Is there any doubt so far, students?
No, ma'am.
Okay, fine. So next that some rays are passing and this is passing from the cathode to the anode, and the next point it has some masses, and so we know that whatever the particle has some masses, which means that they are the particles. So matter is made up of an particles, right? So mass and volume are the main criteria for the particles. So we proved that it has some masses and it has a nature of particle. Next, what we are doing, so instead of the fan, the next time he is placing a magnetic field. Okay, so tell me, on placing the magnetic field, what will happen usually if you place a magnetic field? So now the rays are moving in a straight line. So the spot are on the very straight in the zinc sulfide screen. If you are placing the magnet, what will happen? If you place a magnet, the ray, yeah, yes,
It will get attracted towards the magnet.
very good. It will get attracted towards a magnetic field so that it is deflected. The rays are deflected. Okay, so from that, what we can say? The rays have some charged particle. Are you clear? The rays has some charged particle. Okay, so because of the charges only, it is attracted towards a magnetic field. So as it is attracted towards a magnetic field, then the rays will not moving in a straight line. It will not hit the zinc sulfide screen. Okay, so it has some charged particle. That is what our next point. It has some charged particles. So then, yes, he proved that it has some charged particles. So then he proved it has some masses, right? Masses and all he proved. Then the next case, we have to show that whether it is a positively charged particle or negatively charged particle. Then what he is doing, he is taking the magnet and he is placing the two things. One is actually a positive plate and another one is a negative plate. This is also connected to the battery. Okay, here I didn't draw. So this is also negative plate and this is a positive plate. So where the rays are coming from? The rays are coming from the cathode. What is the charge of the cathode? Negative charges. So the rays are having a negatively charged particle. Then where it will attract, whether it will attract to the negative plate or it will attract to the positive plate?
It attract to positive plate.
Very good. So it will attract to the positive plate. Okay, during this experiment, the rays is attracting to the positive plate, which means that the rays are negatively charged particle. Okay, the rays are negatively charged particle. See, I'll say once again. Okay, in the first experiment, he is saying that the rays are invisible. Okay, by showing some zinc sulfide screen, the rays are moving in a straight line. By placing the zinc sulfide, as we can see some spots or the fluorescence material, the rays are invisible. That is the first point. And the second point, he is placing a very light fan. So the rays falls on the fan so that it will start to rotate, which means that even the invisible ray has some masses, so it is considered as a particle. Then the third one, what he is saying, he is placing a magnet in front in the glass tube. So it has some magnetic field. The rays are moving towards the magnetic field, which means that the invisible ray has a charged one. It's a charged one because only the charged particle will experiences the magnetic field or the electric field. So the charged particles are moving towards the magnetic field, which means the charged particle has some the invisible ray has some charges in it. Then we have to find whether the charges is positive or negative. For that, he placed on two electrodes. One is a negative and another other one is positive. The rays are coming towards a positive electrode. The rays are coming towards a positive electrode means, then what is the character of ray?
Negative charge.
Very good. It is a negatively charged particle. So first he has named as a negatrons. Okay, first he has named on negatrons. That is a negatively charged particle, which is negatrons. Later on, it is changed as an electron. So this is an experiment which proves that atom has a subatomic particle electron, and which is a negatively charged particle. It has some masses, and the electron has some charges proved by the presence of magnetic field. Clear, everyone?
Yes, ma'am.
Okay, very good. Any other doubts? Any doubts here, students?
No, ma'am.
No. Yes. Okay. The same way he is doing for the protons, and he is finding the protons also. Okay. The next experiment is about Mulliken oil drop experiment. So what is a Mulliken oil drop experiment? What's the use of Mulliken oil drop experiment? Anyone know? Just tell me what you have. I'm sure that this chapter is already taken in school, right? What is a Mulliken oil drop experiment? What is the use of Mulliken oil drop experiment, students? No idea? Yes. Okay, see, we can find the value of E by M. This is very important. See, here E denotes actually a charge. And what is an M by E? M by E is a mass of electron. Okay, simply what we will say is charge to mass ratio. This is an important word. So to find out the charge to mass ratio, Mulliken did an oil experiment. So from that experiment, we got the E by ME value, which is simply charge to mass ratio. So we'll see that experiment. I'll show you it in the on image. 1 minute. I'll share the PowerPoint. Just a second. Okay, so this is what the experiment, Mulliken oil drop experiment. Okay, see, it's a kind of a cylindrical container and having two plates. This is a one plate and this is another plate. Hope everyone can see the PowerPoint, right?
Yes, ma'am.
Yes, ma'am.
Okay, yes, fine. So first he is spraying some oil droplets. Okay, so the oil, and here we have a small hole. Through the small hole, the oil is coming to this surface. So and see that the white color plate is actually a positive plate, and this is our negative plate. Okay, so this is a positive, and here we have a negative plate. So this is an X-ray source. So to this way, we will be passing the X-ray. So what will happen is the oil particles will start to ionize. Okay, it will start to ionize. So ionize in the sense, so even the oil has some protons, electrons, and neutrons, right? So it will start to ionize. So electron minus, and then E minus, and then you have a positively charged particle. Oil is now positively charged particles. Electrons are removed from the positively charged particles. So this is what happening in the oil drop experiment. Then what will happen is, then this oil particles will start to coming into this region. So this is a positively oil charge now. Because of X-rays, it started to ionize. Then what will happen is, see, there are two forces acting on it. One is gravitational force. Okay. So what is the formula for gravitational force? What is the force of gravity? I think you have learned in the physics, right? Gravitational force.
Downwards.
It will act towards downwards. And what's the formula? It's an mg, mass into mg. Learned, right, you people?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, okay. So there are two forces acting on it. One is the mg and other force is because of the electrodes. So like we have a positive electrode as well as negative electrodes. So the detailed derivation is not important, but by this experiment, they found the value of E by Me, which is a charge to mass ratio. So charge to mass ratio was calculated. So that is very, very helpful to find out the mass of electron. So this is about simply the Mulliken oil drop experiment. He is spraying the oil. Then in the next case, we have a hole in the positive electrode. So through that hole, the oil is coming and we are passing the X-ray sources. As we are passing the X-ray sources, we have hydrogen also in the container. So the hydrogen gas also starts to ionize. It becomes an H plus and then E minus. The E minus. So now this is also ionized. No, the E minus will be attracted towards a positive charge. So the oil will be completely surrounded by the negatively charged particle. Okay. So I'll repeat. We have an hydrogen gas in the container. As we are passing an X-ray source, the oil also get ionized and then the hydrogen gas also get ionized. So now the oil is actually in positive and then we have an electron minus which is coming from the hydrogen. Okay, the electron minus because of the ionization of hydrogen, this electron minus will falls and will be attacked towards the oil drop because oil drop is a positively charged particle and electron is your negatively charged particle. Now the oil is surrounded by the E minus. So there are two forces acting. One is a gravitational force. The other one is electrode force. Like we have a positive plate here, no. And what is the oil is covered by? The oil is surrounded by the electrons. So now the oil is negatively charged particle which is attracted towards the positive plate. So there are two forces acting on it. So derivation is not important here, students. So from this experiment, he got the value of M by E. So what is the value of M by E? It is a constant value only. Okay, it is an M by E value. I'll show you. See, there are two forces. One is a gravitational and another one is an electrostatic forces. So gravitational force towards downwards and the electrostatic force towards the upwards. So the reason is because the oil is completely attracts the electron from the hydrogen and it is attracted further towards the positive plate. So that is of the reason of electrostatic forces. There are two forces. So here, we check. We'll move to the whiteboard. Is there any doubt in the Mulliken oil drop experiment, students? Clear?
Yes, ma'am.
Okay. So, the main important use of Mulliken oil drop experiment is to find out the E by M by E value, which is so useful to find out the value of M by E. So next is about discovery of proton. So the same experiment, so discovery of proton. In the discovery of proton, who found the proton? Goldstein. Goldstein found the protons. Again, a kind of same experiment. We will be taking a glass tube which is fitted with a vacuum pump, and then low pressure we are maintaining here, and then high voltage. So it is of high voltage. A positive terminal is connected so that this become a positive electrode and this become a negative electrode. So now here we are placing the zinc sulfide. We are coating the zinc sulfide because we are doing a discovery of proton. That's an experiment. So where the rays are coming from?
From anode, ma'am.
Very good. From the anode. So the rays are coming from the anode, like whatever the experiment the J.J. Thomson did, the same way he also did. So as he is placing an zinc sulfide on the surface near to the anode region, near to the cathode region, so the rays are invisible. So as it strikes the zinc sulfide, we can know that the rays are invisible. Again, so he is placing the magnet. So by placing the magnet, the rays are attracted towards a magnet, which means the rays are having some charged particle. Then how can I say that the rays are having a positive charge or negative charge? How can we say the rays are coming from the anode?
It attracts towards negative charge, so it is positive charge.
Very good. So we will be placing actually in two electrode. So one is a negative electrode and other one is a positive electrode. So the rays are coming from the anode and it will attract it towards a negative region. So it will attract it towards a negative region means definitely the ray must be a positively charged particle. Am I right?
Yes, ma'am.
Okay. So the same way he also proved that the proton is having a positively charged particle and it is also called as an anode ray. On the previous experiment, the discovery of electron, that is a cathode ray experiment. The electron rays are also called as a cathode ray or even canal ray. Cathode ray or canal ray, and here it is an for a proton, it is an anode ray. It is an anode ray. Very important thing in the discovery of proton is, so here again the Goldstein has used the hydrogen gas. Okay, so the hydrogen gas starts to ionize so that it becomes a H plus and then electron minus. What is your H plus? How many electrons the H plus has?
One electron.
I'm asking H plus, not simply a hydrogen atom. How many electrons?
2 electrons.
No. See, hydrogen atom. Atomic number of hydrogen atom is 1, which means it has an 1 electron and then 1 proton. Am I right? So H plus. H plus in the sense what? It is losing its 1 electron. So the H plus means we have only a 0 electron. There is no electron in the H plus. We have only a proton count. Am I right or wrong?
Yes, ma'am.
Yes, ma'am. Okay, it has only the proton, not the electron. Okay, so now the H plus in the sense which is not an atom. Here I can't say it's a neutral atom. Now it is an ion and this is completely a proton because there is no electron involved in it. There is no neutron also. It's completely a proton. Okay, so like the very important point for the proton discovery is the rays are completely depends upon the nature of gas taken. But the previously, it's not like that. The discovery of cathode ray or the discovery of electron, the nature of the gas is not a much important role. But here, the nature of a gas is an important role. So as you took H plus is your completely a proton. But instead of taking an H plus, let's take, you are taking an helium gas. Okay, helium gas. So what is an atomic number of helium? 2, right?
2, ma'am.
Yeah, very good. So how many proton it has?
2 protons.
2 protons. Very good. It has 2 protons and then 2 electrons. Let's say that the 2 protons, it becomes ionized so that it becomes an helium 2 plus. Once it is ionized, it becomes a helium 2 plus. Now, by comparing the H plus and then helium 2 plus, This is exactly twice of it. Okay, the mass is exactly twice of it. Why? Because this has a plus one charge. Plus one charge in the sense which has only a one proton. But helium 2 plus means how many proton it has?
Two protons.
It has a two protons, so it is exactly twice of it. So nature of the gas is very important while discovery of protons. But in the electrons it is about simply from the cathode rays. We won't be take much important the nature of gases. Clear, students? Is there any doubt?
No, ma'am.
Okay. Okay. I have a few questions. See how either you can say for even discovery of proton or discovery of electron. So how the scientist has found that the rays are having a charged particle. Based on what experiment they found the ray has some charged particles. By placing what? For example, by placing a fan, they prove that it has some mass particles. It has a particle nature. They proved that. By based on what? They proved that it has some charged particles.
By placing magnets, ma'am.
Very good. By placing in magnets. So the magnets will create a magnetic field. Because of the magnetic field, the rays will travel. The ray will not travel in a straight line. It is deflected. Very good. That is an important point. Magnetic field. Yes. Okay. Then how can we find out whether it is a positive charge or negative charge? By placing what he found the electron is a
Zinc
positive.
sulfate, ma'am.
Zinc sulfide. See, zinc sulfide will be helpful. It's an invisible particle. The rays are actually an invisible. It is just simply says that some rays are coming from the cathode. So my question is, how the scientists found that the rays are positive or negative? Yes. Just by keeping in two electrodes. No, one electrode is a positive and another electrode is a negative. So negative rays are coming means it will attract it towards a positive plate. If the positive rays are coming means it will attract it towards a negative plate. So by placing in two plates, having a one is positive and other one is negative, based on that experiments, he found that the rays are positive or negative. Is this right or wrong?
Yes, ma'am.
Okay. So who found the electrons?
J.J.
student.
Thomson.
Very good. J.J. Thomson. Who found the protons?
Goldstein, ma'am.
Goldstein. Okay. Then what about the other particles, other subatomic particles? What is the third subatomic particle?
Neutron.
Very good. Neutron. So who found the neutrons? Who found the neutrons? Chadwick. Okay, Chadwick found the neutrons. Chadwick scientist only found the neutrons. So here, how the experiment was, he is bombarding in the sense a high rate, high speed is hitting. The molecules are hitting at very extremely high speed. So for that bombardment, he is taking an beryllium. Atomic number is 4 and then mass number is 4. So with the high speed of hitting these two atoms and then helium, atomic number is 4. So on this bombardment of these two atoms, so the molecules formed is the carbon having an atomic number 6 and then mass number 12. Then what is in remaining? You just simply count, see, 4 and 2. So 6 is formed. Okay. And then 9 plus 4. It should be how much? 9 plus 4. It should be an 13, right? But here we are getting only a 12 as a mass number. So there is an other particle that is called as a neutron having mass of 1 and then it is not about atomic number, simply it is 0. Okay, the neutron having mass is 1 and then 0. So by this experiment, he found the neutron. Okay, when the beryllium is bombarded with the helium, bombarded in the sense high speed we are hitting. On that high speed, so carbon atom is formed. Along with that, we are getting a neutron. So neutron means the mass is 1. We know that there are 3 subatomic particles, electron, proton, and then neutron. So who and all very heavy here? Who and all very heavy here?
Neutron, ma'am.
Neutron. Neutron as well as proton. Both the proton and neutrons are heavy. Electron is a very lightest particles. We won't be considering much. That's the reason I'm writing a carbon having an atomic number 16 and then the mass number is 12. So mass number, or what is a mass number constitute? What is a mass number? Atomic number is number of a proton. What is a mass number?
Proton and neutron, ma'am.
Very good. It's a proton. Exactly right. It's a proton and then neutron. Because the neutron has no charges, but it equals to the mass of the proton. Okay, the mass of the proton and neutrons are almost equal, but the electron is very light particles. We won't be considering the electrons. So the same amount of mass is releasing, which is equal to the proton mass. Okay, which is equal to the proton mass, but it does not have any charges, no charges. So Chadwick found the neutron is present in the atom based on the bombardment of atoms. Clear? Clear, everyone?
Yes, ma'am.
Yes. Okay. Yes, I'll give you some important constant values from this experiment. Mass of an electrons. Some important points. So charge of the electrons, like right, QE. So charge of the electron is actually 1.6 into 10 to the power of minus 19 coulomb. And then mass of an electron is 9.1 into 10 to the power of minus 31 kilogram. Then the mass of a proton is 1.67 into 10 to the power of minus 21 kg. Then mass of a proton is equal to 1837 of mass of electron. Then the charge of a neutron, you know, it is on 0. Okay, students. So from this, it is very clear that the charge of electron is given, mass of an electron is given, mass of a proton is given. See the relationship between the mass of a proton and electron. I told you already, the mass of electron is 1837 times is lesser than the mass of electron. That's the reason we are not considering it. Mass is actually, the mass of an electron is very negligible when it considered into the terms of the atomic mass. We won't be taken much importance to the mass of an electron. Okay, one more question. See, how the mass of electron is found? Based on what experiment the mass of electron is found? Yeah, I told you. Just think.
Ma'am, Mulliken oil experiment.
Very good. From the Mulliken oil drop experiment. So this is, I can say, E actually. So Mulliken found E by ME ratios. Okay, mass, that is charge to mass ratio. He found charge to mass ratio, which is most helpful to find out the mass of the electron. That's an important point. Yeah. Next, let's come to the atomic models. So like how the scientists gave what is the structure of atom and how the subatomic particles are in the atom. So in this, the first one is a Thomson model. So we are going to discuss about the atomic model. In this, the first one is Thomson model. So in the Thomson model, so Thomson has considered his model with the watermelon. Hope you have learned, right? Watermelon or with the plum pudding cake. What's the reason why he is relating with the watermelon or the plum pudding cake? Yes. So Thomson said that it is an spherical shape. Why he is relating with the watermelon?
Like the seeds, charges are also involved.
Watermelon, we have some black color seeds that denotes like electrons are scattered.
Super. Okay, then what is the red color part in the watermelon called as? How he compared the red color part with the atom? The flesh part. Okay, the black color seeds he considered as an electron And the fruit part, the red color part is actually a protons. Okay, that is what his consideration while finding the structure of atom. So the structure of atom is a spherical, and then electrons are randomly placed in the atom, and the red color surface is actually a proton. So protons is completely present everywhere in the atom. But is it like that? Is a proton is present everywhere in the atom?
No, ma'am.
No, it is not present everywhere in the atom. But this is the Thomson model and it is on failure, which is totally wrong. Correct. Because proton is present in the center of an atom. Okay. But this is an ideology given by the Thomson in very, very early. This is the first model. Okay. So this model is failure because it does not explain the stability of the atom. So the limitation is stability. He didn't explain. So Thomson didn't explain about the stability of atom. Then explain. So that's a failure model. And he didn't explain about the neutrons also. So even the neutrons is also he didn't explain. He just give explanation about only the proton and then electron. That too is wrong. So next, who is the next model? Next to Thomson model. Yes? Rutherford, right? Rutherford model. So what's the Rutherford model experiment? He did alpha scattering experiment. So alpha, what does mean by alpha? Alpha is your helium particle. What is your alpha? Which is an helium particle, and helium particle is 2He4. This is what your helium particle. When the helium will undergo ionization, it becomes a helium 2 plus, and this is actually a positive charge and positive ray. I can say this is a positive ray. Alpha rays are actually a positive ray. So what he is doing is, he is passing the alpha rays. Let's take, this is an alpha ray and this is a thin gold foil. Okay, very, very, very thin gold foil. Because atoms are very, very smaller particles. Even if you take a thin gold foil, it has millions of atoms, trillions of atoms. Okay, he took very thin gold foil. Thin gold foil. And then he is placing on one zinc sulfide screen here. What is the use of zinc sulfide? What is in zinc sulfide? What's the purpose of zinc sulfide here?
The shiny
Very good. It is a phosphorescent material, or even we can say fluorescent material. If there is any light particle falls on the zinc sulfide, it will start to glow. That is the use of the zinc sulfide screen. So some of the alpha rays are passing in the gold foil, okay, and we can see a bright spotlight on this region. Okay, there is a spotlight on this region. Majorly in this region, because most of the rays are travel in a straight line, and very few are deflected to a slight angle. Very few are deflected to a straight angle. Again, very, very less are deflected to the exactly opposite, which is coming as 180 degree, exactly opposite. So very few are deflected by a small angle, and most of the alpha rays are moving in a straight line, and few of them are exactly deflected back. So what's the observation, or what is the conclusion? What he said from this experiment? Why most of the rays are travel in a straight line? Yes, students, why the most of the rays are travel in a straight line? Okay, I'll draw one more structure so that you can understand. See, this is the atom. Okay, in the center we have a nucleus. The nucleus has proton and then neutron. I have an electrons here. So I am passing the alpha rays. So while passing the alpha rays, most of the rays are traveling in a straight line. Am I correct? Most of the rays are traveling in a straight line. And then very few rays are deflected back. And then I think I'll draw it. Okay. So, and few rays are exactly comes to the bounce back. It is coming bounce back, which is an 180 degree angle, and this is a very slight angle. It is deviated. The reason is he found that The first one, why most of the alpha rays are moving in a straight line? Because there is a much empty spaces in the atom. Okay, it's because of empty spaces in atom. There is more empty spaces in atom. That's the reason the rays are moving in a straight line. Imagine you are going in a car, there is no vehicles in front of you, then definitely you will move in a straight line. If there isn't some two-wheeler or again a four-wheeler, means either you will take left or you will take right. So there is some obstacle. So there is no obstacle in the atom. There is much empty spaces in the atom. That's the reason most of the alpha rays are moving in a straight line. Okay. Sometimes very few alpha rays are deflected. What is the reason why it is deflected? Means I have told you already whether the alpha ray is a positive ray or a negative ray.
Positive ray, ma'am.
Very good. The alpha ray is your positive ray. Exactly right. It's a positive ray. So here you have a positive field. Am I right? So here only you have a nucleus. The nucleus is actually a proton, have some positive field. Whether the positive will attract or it will repel.
Ripples, ma'am.
Very good. It will repel each other. So because of the presence of the proton, the rays are bit deflected. Okay, see carefully. The few alpha rays is not going exactly it is not going exactly touch the nucleus. It is going near to the nucleus region. Okay, it is going near to the nucleus region. Whenever it comes near to the nucleus region, it is get deflected by a small angle because there is some proton field here. There is some positive field here. Because of the positive field, it get deflected. Otherwise, even you can say one more point. As you have an electron minus here, maybe this is a positive ray, it get attracted. So the positive ray will approach towards the electron because it will attract the electron. The positive ray will attract the negative, both are oppositely charged particle. That's the reason very few alpha rays are deflected. Okay, very few alpha rays are deflected by a small angle. Then what about the third case? So second case, deflected by small angle. Deflected by small angle. What is the reason? What's the reason? The ray is also positive and even the proton's field is also positive. So whenever the ray will falls a proton field, so positive will repel each other so that it is deflected by a small angle. And our third ray, the third point is the alpha ray exactly striking the nucleus. So whenever the alpha ray exactly meeting the nucleus, okay, what will happen? It exactly bounce back.
Back.
Yeah, it is coming back to the same place because the nucleus is your proton. Correct. Again, the proton will repel each other. It is coming to the same place. The alpha ray is coming to the same place. Okay, what is the conclusion? The third point is bounce back. So this is what obtained by the experiment. This is the results got from the experiment. So it is very simple. There is an atom with a spherical shape and then most of the atoms are empty and there is a small region for the proton. Okay, so because of the small region only few rays are deflected. Imagine in case instead of a small region, if the proton is like that, if the proton has a big region like this, then what will happen? Most of the alpha rays will be deflected. Am I right or wrong? Suppose if nucleus is big. Right, students? Am I right or wrong?
Yes, ma'am.
Okay, if the nucleus is very big, imagine if the nucleus is very big and alpha ray is also your positive ray. When the alpha ray meets the nucleus, then most of the rays should be deflected. But that is not happening. Only the few rays are deflected and most of the rays are moving in a straight line. So that much empty spaces and nucleus is actually very, very, very small. Okay, when compared to the size of an atom, the nucleus is very, very small. So that is a conclusion made in the Rutherford. Are you people clear? Is there any doubt in the Rutherford model? Any doubts, ma?
No,
No,
ma'am.
ma'am.
Okay, then even though this is not a successful model, again there is some failure. So what's a failure here is, like Rutherford is saying, so he found a proton. He is not talking about neutrons. Okay, there is a proton present in the center, and the electrons are present in the orbit. Electrons are keep on revolving in the orbit. But what will happen? He missed to say this point. So the point is, according to the Maxwell, this is comes from the Maxwell theory. Whenever the charged particles keeps on revolving or keeps on rotating, it will releases energy. Okay, it will releases energy. See, the electron are present in the its orbit. So whenever a charged particle like keep on revolving it or keep on rotation, so by doing some work, so it will loses its energy, and finally it will comes to the nucleus place. Okay, we know that electrons have some charged particle and it is a negatively charged particle. So as because of the revolution, it has some acceleration. Because of the acceleration, it will releases its energy, and finally it will falls into the nucleus. But is this will happen? Is this will happen?
No,
Whereas
ma'am.
no, the electron will not comes to the nucleus place. Definitely, it will not comes to the nucleus place. If electron will comes to the nucleus place means, which means that it is again unstable molecule. So again, the stability is not explained. So it is an unstable. Okay, the stability is not explained by the Rutherford model. So the next model was actually an Bohr model. Clear, everyone? Is there any doubts?
No, ma'am.
Yeah, fine. So the Bohr model, yes. So Bohr model is also very similar to the Rutherford model, but only the difference is here there is no loss of energy. Okay, that is what he is saying. So here you have an protons and electrons are present in the orbit like this. Okay, as it has an own orbit, so protons and neutrons present in the nucleus. We have an electrons in the orbit, that is according to the 2n square formula, the electrons present in the each orbit. So the electrons will revolve, but it will releases energy, but it will not comes to fall in the nucleus. Okay, so here it is explained. Here it explains about the stability case. Clear, everyone? The Bohr's model is about the stability purpose. Is there any doubt so far?
No, ma'am.
Yeah, fine. So next class we will see in detail about the Bohr model. I'll ask you some basic questions from this part. Ready, everyone?
Yes, ma'am.
Okay, fine. So what is the first atomic model?
Thomson model.
Thomson model.
Thomson model. So why that model is failure?
Ma'am, it didn't explain about the stability and neutrons position or about neutrons. He didn't explain, ma'am.
Okay, he didn't explain about the neutron and there is no stability. Okay, what is about neutral? How we can say the atoms are neutral?
Electron and proton are same.
Very good. The electrons and protons are same. Electrons and protons. Okay. So which experiment is helpful to find out the mass of electron?
Mulliken oil experiment, ma'am.
Mulliken oil drop experiment. Okay. So why only the few rays are deflected in the Rutherford model?
Because the
Because it
proton
passes through
less.
the proton.
Oh. Okay, it passes through the protons. Is any other answers?
No, ma'am. Proton mass is less, so that few rays are deflected.
Okay, it is, see, the proton region is very less. Okay, it is not about the proton mass is very less. The proton region is very less and it is a small concentrated circle and there isn't much empty spaces. That's the reason. Okay, so yes, correct. What is the nature of alpha ray?
Positive charge, ma'am.
Positively charged particle. Okay, fine. Then, yes. So, based on what the scientists found that the electron has a mass particle. Electron has particle nature. How he found the electron has particle nature?
Mom, when he kept, I mean, in cathode experiment, he kept a fan, mom. When
Okay.
rays are passing through it, the fan rotates, mom. So that he confirmed that the invisible ray has some mass and it follows particle nature. That means particles have mass and volume. So, electron has
Very
particle
good.
nature.
Yes, exactly right. Super. Yes. See, yes. So phosphorescent. What's a phosphorescent material used in the experiment?
Zinc
Zinc
sulfide.
sulfate.
Very good. Zinc sulfate. Yeah. Any doubts? See,
No,
when
mom.
okay, so
No.
some basic concept of chemistry, it's a kind of a problem, so that it's too interesting. When it comes to structure of atom, maybe few topics about only the history based things. So it might be little difficult to follow up. So wherever you have a doubts, ask me so that you people can get a good clarity. Okay. When compared to the previous chapter, it's kind of bit history oriented. Clear, everyone?
Yes, ma'am.
Yes,
Okay.
mom.
Yes, so we will see the Bose model in the next class. Yeah, thank you. We'll meet in next class.
Thank you,
Thank
ma'am.
you,
Yeah.
ma'am.
So,
Thank you, mom.
okay, ma'am. I'm leaving. Yes.